Okay, so day one here, we're going to look at 10 basic functions. The important part of this is that you must know these without a calculator. So this is part of the reason we're doing this. I know obviously if you just put it in your calculator, you get the graph. But for when you go on to calc, move on in math, these are functions you should really know without a calculator. So the identity function, y equals x, remember y, or f of x is y, so this is like y equals x. That means, if x is 0, y is 0, if x is 1, y is 1, if x is 2, y is 2, x is 3, y is 3, and same into the negatives. -1, -1, -2, -2, -3, -3. And then you make a straight line. Some of this might be a little hard for me here on the screen to do. So domain is all reals, which a lot of times we notate with that R with the double bar. So all reals, or you could say negative infinity to positive infinity. So there's even people that'll say for domain, X. I guess for this, we'd still be saying kind of like all reals. Constant function, I'm just going to pick a f of x, let's say equals 3. So of course that means y equals 3, which means y is always at 3. So 0, 3, 1, 3, 2, 3, -1, 3, -2, 3, and all the decimals in between. So you're connecting that line, where y is 3. So for my graph, domain would be all reals. My range would just be 3. So just hard bracket 3. Absolute value. Well, if you think of plugging in, absolute value is 0 is 0. Absolute value of 1 is 1. 2 is 2. 3 is 3. The absolute value of -1 is positive 1. Absolute value of -2 is positive 2. -3 is positive 3. So the absolute value looks like a V shape. Domain, all reals. Range, hard bracket 0 to infinity, or sometimes people will say y greater than or equal to 0. For the quadratic function, and maybe I don't have to make a table, but just for the sake of your notes, so you know what points I'm plotting. So if x is 0, 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. If I do some negatives, -1 squared is 1. -2 squared is positive 4. -3 squared is positive 9. So 0, 0, 1, 1, 2, 1, 2, 3, 4, and 3, we go 5, 6, 7, 8, 9. And then same thing on the other side. Oops, wait a minute. Oh, I'm a little off there. So it should be -2, 4, and then -3, 9. So I used to always give a quiz on this without a calculator. I don't know if we'll have time for that this year, but this is stuff you should know without a calculator. And I was always very particular about the points. You got to make sure you have the right points labeled or plotted. The reciprocal function It's called the reciprocal function because that's exactly what the points are. They're reciprocals. Now, first of all, if x is 0, this thing is undefined, which lets me know there's a vertical asymptote at x equals 0. So I'm kind of just putting a dashed line there. So that's something we're going to approach. We're not going to cross it. Now, if I put 1 in for x, I get 1 for y. If I put 2 in for x, I get a half for y. So 1, 1, 2, a half. And then sometimes I like to be able to tell what it's doing toward the asymptote. So then I put a half in for x, and that means y would be 2. So if you think about it, it's 1 over 1/2. 1 divided by a half means 1 times its reciprocal, which is 2, So that's, one way that I'm getting that. So at a half, we'd be at 2. So you can see it's approaching the asymptote. And there's also a horizontal asymptote here. Okay, then reciprocal of -1 is -1. -2 is -1/2, and -1/2 is -2. And that's, again, just plugging in, but that's how we're, getting those values. All right, so domain is all reals except 0. Range is all reals except 0. So that means except for. And then you should put it in the set notation. You don't want to do parentheses or hard brackets because then it kind of looks like interval notation. I guess hard brackets would be fine there. But that's how we usually write it. Well, all reals except for. Now, you could write the words out. You could say all reals except for 0. Or you could say -infinity to 0, u 0 to infinity. That's another way. Now, the signum graph, this is one that you may have never seen before. It's actually a pretty easy graph. Signum graph has a point at 0, 0. Any positive x value has a y value of 1, and any negative x value has a y value at -1. So what it looks like, we got the dot at 0, 0. 0, 1 is an open circle, and then a line going to the right. So anything that's positive, if I'm at 0.1, I'm at 1. If I'm at 1, I'm at 1. If I'm at 5.5, I'm at 1. And then at 0, -1, there's an open circle and a line to the left. If you think about it, those circles have to be open because these are functions. And what we're going to kind of review in a couple of days is that functions have to pass the vertical line test. So if I had these all closed circles at like 0, 1, 0, 0, 0, -1, that would not pass the vertical line test. So the domain is all reals. The range is just -1, 0, and 1. Those are the only y values in this graph. Cubic function, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. -1 cubed is -1, and -2 cubed is -8. domain, range are all reals. So I'm going through 0, 0, 1, 1, 2, 8, and then -1, -1, -2, -8. Okay, greatest integer function. We want to know closed on the left, open on right, line connecting open and closed circles. Okay, so this is what it looks like. Closed circle at 0, 0, then there's a line, and then open at 1, 0. Then it goes closed, line going over, open. So line going over to the next integer. So closed, line, open. So here, open on the right, line closed on the left. Open, line, closed. So this is sometimes called a step function. And they'll, oh, this looks a little weird. This should be a double hard bracket. So one way they write it, f of x equals, and it looks like that. Or sometimes you'll see it, the int of x. This is all reals. And the range is the integers. So that's why it's at steps. It's at 0, it's at 1, it's at 2, it's down at -1, it's down at -2. There are steps to it. Square root function, square root of 0 is 0. Now square root of 1 is 1. Square root of 2, not such a nice number. Square root of 3, not such a nice number. Square root of 4, though, we know is 2. And square root of 9, we know is 3. So that's what my square root function looks like. 0 to infinity, range 0 to infinity. Um, 0, 0, 1, 1, 8, 2. So the cubic root of 8 is 2. Cubic root of -1 is -1. Cubic root of -8 is -2. Kind of looks like this stretched out S-looking shape. So 0, 0, we're going for 1, 1, we're going through 8, 2, -1, -1, -8, -2. Sometimes people will say to me in this graph, well, I thought you can't have a negative under a radical. Well, if it's a cubic root, remember you can. Cubic root of -8 is -2. That's because -2 multiplied together 3 times gives you -8. Domain and range are all reals for these. Okay, so we also sometimes have some of these evaluate problems. So it says f of x equals signum of x plus int of x. Find f of the cubic root of -9. Okay, this I would have to put in the calculator, cubic root of -9, which is about -1.2. So this is SGN of negative, or did I say that backward? -2.1. So SGN of negative 2.1 plus INT of negative 2.1. Now, for SGN of negative 2.1, if you go back to the signum graph, so if we went back up here, we know for signum of anything positive is positive 1, negative is negative 1, signum of 0 is 0. So if we come back down here, signum of anything negative is negative 1. Now for INT of negative 1.2, or I keep saying negative 1.2, negative 2.1, we are going to actually go to the next integer to the left. So going back to the greatest integer function, that's one that sometimes people will call the birthday function, because which works if you think of it in the positive direction. It's kind of like saying if you're 16.9 years old, you're still 16, right? You're not 17 until you hit your next birthday. So it rounds it down to the next integer. So the same thing happens in the negatives. Like if I thought of if I went to negative 2.1 on this graph, this is open here, line to the left. So at negative 2.1, I'm down here at negative 3 for a y value. So for INT, go, I won't even say round because we don't want to think of typical rounding properties. Go to the next smaller integer. And if you think of it on a number line, next integer to the left. So negative 4. Absolute value of negative 8 is 8. SGN of 3, well, remember signum of anything positive is positive 1. INT of 5.1, if you're 5.1 years old, you're still just 5. Next integer to the left. 8 minus 1, 7. 7 plus 5, 12. Okay, this one, 3. Now, INT of negative 2.2. INT, remember you go to the next integer to the left. So if you were on a number line, the next integer to the left of negative 2.2 is negative 3. Plus 5 times SGN of negative 2.2 is a negative 1. Because remember, signum of anything negative is negative 1. So this is negative 9 plus negative 5, which is negative 14. Okay, that's it for day 1.